In this problem, a balloon is rising at a constant speed of 5 feet per second. A boy is cycling along a straight road at a speed of 15 feet per second. Then we read he passes under the balloon. Okay. And the question is how fast is the distance between the boy and the balloon increasing 3 seconds later? Okay, so we have here, let's zoom. Okay, so here we have the balloon that is going up. Okay. And then here we have the road. There. And here we have the cyclist. Okay, that is moving to the left, let's say. To the right, sorry. Then let's call y the vertical to the balloon, and then let's call x the movement from that vertical. And then let's consider here the distance from wherever the boy reaches. Let's place him here. Let's call it 8. Okay, so we have, there we go. Here we have our variables. And so we know the rates are, so the boy is cycling at the speed of 15 feet per second. So that's the rate. And then the balloon is rising at 5 feet per second. So this is 5. Okay, and then what we know is when the boy passes under the balloon, let's say that's t equals 0, and then we want to know what happens 3 seconds later. Okay. So I think we are all set, because clearly the formula for h is h squared equals y squared plus x squared. And the way we get the related rates here is differentiating both sides respect to time. Okay, so we get 2h prime equals 2y prime plus 2x x prime. Careful here, we are not differentiating respect to x, we are differentiating respect to time, which is, let's say, t. We haven't even written it here explicitly. And then 2 disappears, and we get h prime equal to what? Equal to y prime plus x prime divided by h. And we are almost there, because we have y prime, we know it is 5 feet per second. X prime, we know it. So we need to figure out x, y, and h. Now from the problem, it says that it's rising at a constant speed. And also the boy is cycling at a constant speed. So that makes it easy for us, because then y is going to be, well, so let's put y of 0. Okay, this we know is 45 feet, because the problem says so. Okay, when he passes under the balloon, it's 45 feet above him. Okay, so we want to know what is y of 3. Okay, but that is equal to y of 0 plus the speed, which is 5 feet per second, times 3 seconds. So that's 45 feet plus 15 feet. That makes 60 feet. So that's the y we need. And then what is x? So x of 0 is 0. Okay, because it's when the boy was right under the balloon. And then he displaces from there. X of 3 will be 15 feet per second times 3 seconds. So that makes 45 feet. And with this information, now h prime is 60 feet times y prime, which we said was 5 feet per second, plus x, which is 45 feet, times 15 feet per second, divided by h. I forgot that one. All right, so h of 3 is the square root of x at 3 squared plus y 3 squared, Pythagorean theorem. And this is the square root of 45 to the power 2 plus 60 to the power 2. And when you compute this, you get the square root is actually 13. No, 75. 75 feet. Oops, that's not the final result. So we divide by 75 feet, going back to where we were. And now this gives well, you do the detailed computation, this gives 13 feet per second.